November 2023, paper 2, variant 3. Question 1. How many quantities shown are scalars? How many of them are scalars? Mass, momentum, no, density, and energy. So only 3 of them. A train is on a straight track. The graph shows how the quantity y varies with time. Which statements can be true? So there is a quantity y, and it's varying with time. As we can see that this y is constant, right? The train is stationary, and y represents the distance. So if you write down distance on the y-axis, would the train be stationary? It would be stationary. Yes, it would be stationary. The train is moving and y represents the distance. No, it's not the distance. The train is stationary and y represents the speed instead of writing down distance. Would this show a stationary object? No, it wouldn't show a stationary object. The train is moving and y represents the speed of the train. Yes, the train is moving, and actually it would be moving at a constant speed. So only 1 and 4 are correct. It's moving with a constant speed. Diagram shows how the speed time graph for the moving object. Which description of the object's motion is correct? Which description of this motion? What's happening to the... Is it accelerating or not? It is accelerating. With a constant acceleration? No, with a decreasing acceleration. Yes, decreasing acceleration. The mass of the air hitting the blades each second is 1.5 times 10 to the power of 4. The speed is 4. The density of the air is 1.2 kilograms. Which row gives the volume of the air hitting, the blades, and which row gives the kinetic energy each second? Can I find the volume? Yes, you have the density and the mass. So density equals mass over volume, or volume equals density. Volume equals mass over density, right? Mass over density. So the mass is 1.5 times 10 to the power of 4, and the density is 1.2, right? 1.5 times 10 to the power of 4 divided by 1.2 will give you a number very close to 13,000. Can I find the kinetic energy? Yes, half mv squared. Half mv squared. Half times 1.5 times 10 to the power of 4 times the velocity, which is 4 squared, giving you a huge number, almost 120,000 joules. Definitely a huge number. An object moves in a circle around a constant speed. It's moving with a constant speed. Which statement about the force needed on the object is correct? Which statement about the force needed is correct? The force when moving with a constant speed. We know that the force, this is a centripetal force towards the center of the motion, which is perpendicular to the motion, right? Force away from the, no, not away. Force is in the direction of the motion, no. Force towards the center keeps the object moving in a circle, yes. No force is needed, no, there is a force needed. So it's only C. Which diagram shows the rod in equilibrium? This is a really easy question. It's A. I think it's very obvious that it is A. Why can't B be correct? B has to be wrong. Why? Because this rod will actually move upwards. This object will move. It won't rotate, no, but it will move upwards. Why? Because there is no downward force. Is there an upward force in A? Yes, there is an upward force acting at the pivot. Right? Okay. A car of mass 1,200 kilograms is traveling along a straight horizontal road. Which impulse is needed to accelerate the car from 5 to 10 meters per second? Can I find the impulse? Yes, mv minus mu. Change in momentum, mv minus mu. So basically 1,200 times 10 minus 1,200 times 5. We do not need to change the sign of the velocity. Why? Because it's moving in the same direction, right? 1,200 times 5, which would be 6,000 Newton seconds. A mass bounces up and down on a steel spring. At which point is the least energy? in the gravitational potential store. Okay, and at which point is the most energy in the elastic? You need the least GPE and most elastic. Least gravitational potential energy would mean that it is the closest to the ground, right? The closest to the ground. At which point is it the closest to the ground at the lowest point, right? It's the closest to the ground. What about the most elastic potential energy? The most elastic energy would be stored when it is stretched out the most, right? When it's stretched out the most, indicating or thus it would be the lowest point as well. Both of them would be the lowest point. Hmm. A boy uses a rope to pull an object of mass m up a slope. The rope is parallel to the slope. Okay, the tension in the rope has a force, a value of F. This is the force, the tension in the rope. The object moves a distance d along the slope and rises through a height h. How much work is done by the boy? Can I find the work done? Yes, work done would be the force times distance moved. Force times the distance moved. So the force would be F and the distance moved. Is it D or is it H? Hmm. Is it D or is it H? It's actually D because this is the distance moved by the object up the slope. If he had asked, what is the work done against gravity, for example, we would have said mgh, right? If he asked about the gravity, if it was related to the gravitational potential energy, but it's not. A microwave oven is rated at 900 watts. Which statement correctly describes the meaning of this value? 900 watts. What does this mean? 900 joules are transferred every second. Power equals energy over time. 900 joules per second. Yes, this is correct. An object is immersed in a liquid of density rho. The pressure is P. The gravitational field strength is G. Can I find the depth, height? Yes, pressure equals rho GH. To find the height, it would be pressure over rho G. Pressure over rho G. A sealed bottle has a constant volume. The air is heated by the sun, which affect on the average speed and the distance. So what happens to speed and what happens to distance? If the volume is constant, if the volume is constant, will the distance increase? No, the distance would stay the same. What about the speed? The speed would increase since the kinetic energy increases due to the heat. In an experiment to investigate the relationship between the volume of a sample of air and its pressure, the volume of the sample is decreased and the pressure is measured. Curve X on the graph shows the result that would be expected for a fixed mass of air at constant temperature. Curve Y shows the results that are obtained for this particular experiment. So it's quite obvious that as the volume increases, the pressure decreases, and vice versa. They are inversely proportional. Which row shows two possible reasons why curve Y is different? Why curve Y is different? Let's see. The temperature of the air increases as the volume is decreased. Okay, the temperature of the air increases as the volume is decreased. Why is different? This would mean, okay, why is the actual, isn't why the actual results? Yes, it is the actual results. So if this were true, if this statement was true, if the temperature increases, would this give a pressure which is less than the expected? It actually would give a pressure higher than expected. Again, it would actually give a pressure higher than expected. This is the actual results. Y is the actual results. And X was the calculated results, for example, or the expected results in X. So Y is now less. The pressure is actually less. Would the pressure be actually less if the temperature had increased? No. It would be less if the temperature had decreased. If the temperature had decreased. Air leaks into the container or out of the container. Would the air be leaked into the container or out of the container? Again, if you think about it, if you leak air into the container, this would mean that you'd have more more air molecules, and these extra air molecules would increase the pressure. Why would they increase the pressure? Because they would hit the walls more frequently and the pressure would increase, even though in Y the pressure has decreased. Therefore, the only possible solution would be that the air was leaking out of the container. It was leaking out of the container, thus leading to a decrease in the pressure. So it was leaking out of the container. D. A student splashes water onto her face. Here are three statements about the effects. The water uses energy to evaporate. The water gains energy from the student. The face of the student cools. Okay, let's see. The water uses energy to evaporate. Yes, it does. The water gains energy from the student. Again, it does. Okay, to evaporate. The face of the student cools. Yes, due to the cooling effect. Evaporation. Hmm. From which container does the water now evaporate more slowly than it did before? Again, four containers each contain water. More water at the same temperature. More water as the at the same temperature is added to each container. Is added to. From which container does water now evaporate more slowly than it did before? More slowly. If you think about it, more slowly. A, B, or C, or D. What would the only difference be? What would the only difference be? The surface area, right? More slowly. So if you think about it, you'd find that the surface area of C is slightly less when you add water. Again, four containers each contain water. More water at the same temperature is added. So from which container does now the water evaporate more slowly than it did before? We'll cancel out D and B. If you add water all the way to the top, you'd find that C would evaporate more slowly. Okay. Now you have this cupboard and you have the heater behind it. Air can move freely through this gap. Which row describes the temperature and the direction of the air movement in the gap? So if you have hot air from the heater, in which direction will this hot air move? The hot air will definitely move upwards, right? Hot air will definitely move upwards. This is the hot air. It needs to be replaced by some other air, which would definitely be colder air, right? Because this is a heater, so this hot air will be definitely be replaced by colder air. From which direction will this, or from where will this cold air come from? It would move through the air gap, right? It would move through the air gap in this direction. Why? Because it needs to replenish. It needs to replace this displaced hot air. So the cold air will move in this direction. The air temperature has to be cool, and the direction towards the heater. Towards the heater. Light diffracts when it enters a telescope. This causes the image to blur slightly. The amount of diffraction depends on the diameter of the hole through which the light enters the telescope. Which combination of diameter and wavelength would result in the sharpest image? Least blurring. Least blurring. This blurring is due to what? This blurring is due to the diffraction, right? He's talking about diffraction. So I need the least blurring or the least diffraction. What should I do to the diameter of this telescope? I need to increase it. Think about it as a gap. What should you do to the gap? You should increase the gap. You should increase the width of this gap. What about the wavelength? You should just have a shorter wavelength, larger diameter and a shorter wavelength. What is the amplitude? It's P. What is the wavelength? It is S. What happens if monochromatic light is used instead of white light? in this dispersion, what would happen? Instead of using white light, you used monochromatic light. Monochromatic is one wavelength, right? One wavelength. Light changes color. Would it change color? No, monochromatic. The light forms a brighter spectrum. Again, this is monochromatic. Only one light is passing through. There is no reflected light. No, some of the light will be reflected. Some of it will be reflected, definitely. There is no dispersion. Yes, it wouldn't disperse anymore because it's already monochromatic. It's already red light passing or blue light or whatever. So it's only one light passing already. You cannot disperse monochromatic light. What is the angle of reflection? 35, is it? No, it's not 35. It has to be 55. Why? Because the angle of incidence is actually 55. 90 minus 35. At which position is the image of the top of the object formed? You have an object and you have a real image. A real image which is formed on this photosensitive surface. At which position is this image formed? It has to be inverted. So it will be formed at C. It has to be inverted, right? Because this is a real image formed by a camera. Light is traveling through air. It strikes a glass block at an angle of incidence 45 degrees. The glass has a refractive index of 1.4. What is the angle of refraction as it enters the block? We need to find the angle of refraction inside the medium. We know that the equation n equals sine air over sine medium. To find the angle, to find the theta m, it would be sine inverse sine air over n, right? So basically sine inverse, okay, sine 45 over 1.4, right? What's sine 45? Sine inverse sine 45 over 1.4. This would be around 30 degrees. Which row gives appropriate values for the speed of sound in copper, water, and air? Copper, it has to be the greatest value, 4,500. And water, it has to be slightly less, 1,500. And in air, much less, 350. Which metal can be attracted by a magnet? Iron. Okay. Diagram shows an electric circuit. In which direction do the free moving electrons move? And what is the quantity measured by the ammeter? Free moving electrons, they move from the negative terminal to the positive terminal, right? In an anti-clockwise manner. Quantity measured by the ammeter, is it the total charge passing through the ammeter, the charge passing per unit time? Yes, per unit time. This is the current charge passing per unit time, not the total charge. Which substances can both contain large concentrations of free moving electrons? Basically, we need two metals. Two metals would be silver and gold. A resistance wire of length L melts and has to be replaced with a wire of the same material, same resistance. The only wire available has twice the diameter of the broken wire. Which length of this wire should be used? Okay, so twice the diameter means that you will... How will the resistance change if you multiply the diameter by 2? How will the resistance change? The resistance will decrease by a factor of 4, right? The resistance would decrease by a factor of 4. Why would it decrease by a factor of 4? Because we know that the diameter and the resistance are inversely proportional with a square factor, right? They are inversely proportional with a square factor. As the diameter increases, the resistance decreases, but squared. So the resistance would decrease by 4. So if you want the same resistance, which length of wire should be used if you want the same resistance? So the resistance has already decreased because of the diameter. What should you do? What should you do to the length? What should I do to the length? I should Yes, I should increase it. By how much? By 4 times. You should multiply the length by 4. Why? Because if you increase the length by 4, the resistance will be multiplied by 4. So as you multiply by 4 and divide by 4, you'd have the same final resistance R. Okay? Okay. Teacher wishes to show the production of electrostatic charges, I'm sorry. She holds a rod and rubs it to the cotton cloth. The rod a copper rod, a glass rod, and a plastic rod and a steel rod are available. Which two rods would both be suitable to use? Which rods are used? You cannot use metals. Again, you cannot use metals to show the electrostatic forces, the electrostatic charges. You have to use non-metals. So only the glass rod and the plastic rod can be used. Only the glass rod and the plastic rod can be used. Two resistors, R1 and R2, are shown as a potential divider. What is the relationship between R1 and V1, R2 and V2? So say that R1 and V1, R2 and V2, they are directly proportional. Directly proportional. Okay, it has to be written this way. They are directly proportional. There is a ratio. Diagram shows the light dependent resistor LDR. The brightness of the following on the brightness of the light falling on the LDR is increased. So as the light increases, what happens to the resistance? The resistance decreases. What happens to voltage? The voltage decreases. So the resistance on the LDR decreases. The reading on the voltmeter also decreases. If he asks about the resistance, or if he asks about the potential difference of the other resistor, it would increase. Yes, it would increase. Okay. A simple AC generator has a coil rotating in a magnetic field. What happens to the peak? Okay, to the peak EMF and the frequency output when it is moved faster. When you rotate it much faster, what happens? The amount of EMF generated is greater. What about the frequency? It's also greater as you increase the speed of this rotation. A current passing along the wire. Okay, now it's placed between this magnet. The wire experiences a force due to the magnetic field, right? North and south. What will change the direction of the force? Changing the direction of the force. He's not asking about the direction of the force. He's not asking which direction is the force already moving. He's asking what will change the direction of this force. Increasing the current? No. Reversing the direction? Yes. To change the force. What is a transformer used for? Transformers, they are used for what? Changing direct current, no, this is diode. Changing the magnitude of an alternating voltage. Alternating voltage, yes, you can change the magnitude. Increasing it or decreasing it using a step up or a step down transformer. A scattering of alpha particles by a thin gold foil provides the evidence for a nuclear model. Okay. Two alpha particles of the same energy are incident. Okay. Which diagram shows the correct paths of these alpha particles? A, B, C, or D? Now, you have the nucleus, right? You have the nucleus. What will happen to these alpha particles? They would be repelled. So in B, you cannot, it wouldn't be attracted. In D, it cannot be attracted. So it's either A or B. Is A correct or is, I'm sorry, it would be either A or C. Is A correct or C? Hmm. The closer one would be repelled much stronger than the further one. So C is wrong. Why? Because the first one is much closer to the nucleus. So the force of repulsion would be much stronger than the second one. It would be repelled. Yes, it is still repelled, right? It is still repelled, but with a much weaker force than C. So A is correct. Half-life of carbon is 5,700 years. An object containing carbon-14, okay, count rate of 100 counts per minute when it is first formed. The graph shows how the count rate decreases over time. Which point on the graph corresponds to a time of 11,400 years after the formation of the object. What is 11,400 years? This means after two half-lives, right? Two half-lives. 5,700, if you multiply by 2, this would be 11,400 years. So two half-lives. Two half-lives. You will divide by 2. You will divide by 2. How many times? 2 times. What was the initial count rate? It was 100. So 100 divided by 2 is 50. And then 50 divided by 2 is 25. Where is 25? This is 100, this is 75, this is 50, and this is 25. It's at D. That's it. Now, question 36. Why are the beta particles diffracted more strongly? Why are the beta particles diffracted more strongly than alpha particles when they enter an electric field? When they enter an electric field. Beta particles deflection with the alpha. Why are more strongly, even though their ionization effect is much weaker? Because of the mass. Yes, because of the mass. They could be moved much more easier than the alpha particles. Which statement describes how nuclear energy is released by fission? Fission, splitting, right? Fission is the splitting. So having nuclei split into lighter nuclei. Question 38, you have objects X, Y, and Z rotating around S. The time for orbit of Y is 3 times that of X. And for Z is twice that of Y. Again, Y takes 3 times X. And Z takes 2 times, not X, Y. Okay? Takes 2 times of Y. Starting from the initial arrangement, which diagram shows the positions of the planets after X has made one complete orbit. After X has made one complete orbit. So X returns to its original position. What happens to Y and what happens to Z? You'd say that Z has to be behind Y, right? Z cannot move further than Y. So A is wrong because Z has moved further than Y, and C is also wrong. So it's either B or D. Right? It's either B or D. And they both seem to be correct. They might seem to be correct, B or D. Should it be B or should it be D? He said that the time taken for Y is it takes 3 times longer, right? It takes 3 times longer than X. So if X completes one full circuit, if X completes 360 degrees, this is one complete circuit. Y will complete what? Y will complete only 120, right? It will only complete 120 degrees, which is 1/3 of a circuit, right? 1/3 of a. What about Z? Z takes twice the time of Y. Twice the time of Y, meaning that Z will only complete 60 degrees. Only complete 60 degrees. So which of these is 120 and 60? 120 would be at Y, at B, right? And 60 would be at Z. This is B. If you take the initial reading to be 0 at this position, so this is 60 degrees for Z and then 120 degrees for Y. D would be wrong. Why? Because Z would be 120 degrees and Y would be 240 degrees, which is wrong. I know this question might be a bit tricky. The nearest star to the Sun is about 4 light years away from the Earth. 4 light years away from Earth. Student makes 3 statements about the star. Light from the star takes about 4 years to reach the Earth. Yes, 4 light years away, so light takes about 4 years to reach the Earth. Okay, this seems right. Light from the sun takes about 4 years to travel to the star and back to the Earth. Light from the sun takes 4 years. Yes, it does take 4 years to travel to this star. Does it take 4 years to just travel to the star and back? No, it would actually take 8 years. The star is outside our galaxy. No, our galaxy is 100,000 light years. So only one is correct. What is the average orbital speed of the planet? We know that the average orbital speed would be 2 pi r over t. Okay.